All right, today we're going to be learning about how to graph parabolas or quadratics in standard form. So standard form of an equation looks like this. Y equals ax squared plus bx plus c. So a is the number in front of x squared, b is the number in front of x, and c is the number on the end. So step one, we're going to write the axis of symmetry, or find the axis of symmetry. And this is going to be the formula x equals negative b divided by 2a. Next, we're going to find the vertex. If you recall from vertex form, whatever number the axis of symmetry is at, that's also the x value of the vertex. And then to find the y value, we're going to plug in this x value to our original equation. Step 3, we're going to find the y-intercept. Which is going to be the point 0, c. So whatever our value is on the end, that's going to be our y-intercept. And then we're going to plot the vertex and graph using our quadratic pattern. All right, so let's look at some examples. Example number 1, we have y equals negative x squared plus 2x plus 3. So from this, we know a equals negative 1, b equals 2, and c equals 3. So to find our axis of symmetry, we know we're going negative b divided by 2 times a. So it would be negative 2 divided by negative 2, which will give us a positive 1. So our axis of symmetry is at x equals 1. And we also know that that will be the x part of our vertex. So next we need to find the y part of our vertex. And we're going to do that by plugging 1 in for both the x's in our original equation. So we would have negative parentheses 1 squared plus 2 times 1 plus 3. You could also store 1 for x, like we did with absolute value, and then type in the problem with the x's in there. So 1 store for x, and then type the original problem, negative x squared plus 2x plus 3. Enter. So the y part of our vertex is at 4. Our y-intercept, since c is 3, the y-intercept will be at 0, 3. Roots we'll come back to in a minute after we've graphed. The domain we know is always negative infinity to infinity for quadratics. The range, since a is a negative number, we know the range will have negative infinity. And then our vertex will be our highest point, so it will stop at 4. And our end behavior. Since a is negative, we know the arrows will both be pointing down. So let's graph it. We're going to start at 1, 4. And we're going to use our squared pattern, and remember, because a is -1, we'll go down instead of up. Let's also graph our axis of symmetry to make it easier to reflect our points when we're done. So 1 squared is 1, so we go over 1, down 1. 2 squared is 4, down 4. 3 squared is 9, down 9. And that's all we can fit on this graph paper. So we're going to reflect them over. And connect our dots to make our parabola. I highly recommend that you check your y-intercept with where you plotted your y-intercept on your graph to help check that your y-intercept is either written correctly or that you graphed correctly. Remember, roots means the same thing as x-intercepts, zeros, or solutions. So it is the point -1, 0, and 3, 0. In our next example, a is 2, b is -4, and c is 3. So first we need to find out our axis of symmetry. So we're going to have -b. Negative is going to make it positive over 2 times a. So we have 4 over 4, which is 1. So x equals 1, and the vertex is at 1. So we need to find out the y part of our vertex. We're going to do this by plugging into our equation. So 1 store for x, and type the original problem. 2x squared minus 4x plus 3. So the y part of our vertex is at 1. So I'm going to plot that on our graph and plot our x-intercept. Our y-intercept will be the point 0, 3, because 3 is our c. Domain's always -infinity to infinity. Since for the range, since a is positive, we know we'll have positive infinity, and our y part of our vertex, and then end behavior. Since a is positive, both ends will be going towards positive infinity. So now let's continue, graph our pattern. Since a is 2, remember we need to double how much we go up at each point. So if we go over 1, 1 squared is 1, double that, go up 2. 2 squared is 4, double that, we want to go up 8. That'll go off a little bit, but I'm going to plot them on there. Reflect them over to the other side, and make our parabola. On any quiz or test that you have for my class, at least 5 points will fit on the graph paper. So that's a way to check yourself to make sure that you're doing things correctly. So based on this, there are no, and we're going to say real, zeros, since it does not cross the x-axis. Now let's look at one where we have the graph and we go back to the standard form equation. We're going to start off by writing this in vertex form. So we're going to need a, h, and k from our last lesson. H and k would be -3, 1. And since we went over 1, down 1, we know a is -1. So we know that y equals -x plus 3 squared plus 1. So the first thing we need to do is get rid of this squared. And if you recall, squaring means to multiply something by itself. So we're going to have -x plus 3 times x plus 3 plus 1. To make things a little easier, I'm going to distribute the negative into our first parentheses first. You only change the first parentheses. And then we need to multiply out these two parentheses. Negative x times negative x, or sorry, negative x times positive x would be negative x squared. Negative x times positive 3 would be negative 3x. Negative 3 times x would be negative 3x. And then negative 3 times positive 3 would be negative 9. Bring down the plus 1 on the end. And our last step is to combine all our like terms. So y equals negative x squared. If we combine these, we get negative 6x. And if we combine these, we get negative 8. That's all for today. See you in class.